All right, so the first one given to me is that f of x is equal to 7x squared. It's a quadratic. And then the next one given to me is that g of x is equal to 4x. 4x minus 2. And then I'm told to find f minus g of x. So I'm told to find f minus g of x. Oh, well, here I'm not actually given a number. So it'll be difficult for me to use calculator to do it. But so what does it mean? The first function minus the second function. I can combine them. So f minus g of x means bring down the first function, which is f. So I have 7x squared minus bring down everything in g of x. Bring down, that's 4x minus 2. Open the parentheses. So I have 7x squared minus, if I distribute minus into the parentheses, then I have minus 4x. So I'm going to change the sign to 4x. Minus again, I'll change the sign to 2. So I end up with, I just ended with a quadratic function in standard form. Therefore, f minus g of x is a quadratic equation in standard form. And there is no other manipulations here. You leave it. This is your answer. There is no other manipulation here. You use it. This is your answer. And you can eyeball the options. Every question doesn't have option. Will not have option, but this one does. So you check and see if you can get an answer. But let's see. Okay, and I want to make sure that, okay, everybody look. So there is this minus here that was not in the original equation. That minus there was not in the original equation, so I took it off. And so go back and do this minor corrections. So you can always eyeball what you have. So here should be negative 4x plus 2. Why? Because this one didn't contain negative before. All right, this is how to do number 2. Let's go to number 2. By the time we do 2 of them, 3 of them, you understand it. So it's not that bad. All right, so number 2, we are told to evaluate a function. This time I'm told to find f multiply g. Remember, f minus and f plus are not the same. So this is multiplication. F times g of x. That's what this one is saying. So I'll bring down my f of x. That is x squared minus 2. And I'll bring down my g of x. It is x minus 8. 8 minus x, sorry. 8 minus x. All right. 8 minus x in parentheses. What do? You will distribute, multiply one function with the other. Remember, you can FOIL it. By the way, you cannot multiply this with your calculator. So there are things you'll be given you must do algebraically or analytically. You cannot do this one by calculator. All right, so f multiply g of x equals, so I'm foiling, so I'm going to choose one of, let me use a red. All right, x squared multiply x squared multiply negative x, negative 2 multiply. So I have just done the foiling here, and I'll take time to multiply and bring them down. That's what I'm supposed to do. So x squared multiply 8 is 8x squared. 8x squared. X squared multiply negative x. I have negative x cubed. Then I'm done with the first one. First, outside, inside, last. Okay, now the second one. Negative 2 multiply 8, multiply positive 8 is negative 16. Negative 2 multiply negative x is negative, negative is positive. So I have plus 2x. So at this point, I can tidy up, collect like terms, and if possible, rewrite your answer in the standard form of a polynomial. A polynomial has decreasing coefficients, and all the exponents of a polynomial must be integers. It cannot be a negative integer either. It can be x to power 0, but it cannot be x to power negative. So we can say that all the exponents of x must be positive integers. Okay, so collecting like terms, well, the highest exponent is cubed. So my answer will be negative x cubed. And the next exponent is plus 8x squared. I'm trying to write it in standard form of a polynomial. And then the linear term is 2x. The constant term is negative 16. Therefore, f multiply g of x is a cubic polynomial. F multiply g of x is a cubic polynomial. All right, any questions so far? Unmute yourself and ask a question. Unmute yourself and ask a question. Any question? All right. If there is no question, we will continue with 2.6. You really need 2.6 to get into your calculus 1 class. You really need this because very soon you'll be given to a binomial to multiply and then use function of a function to find the derivative of something. You have to first of all know how to manipulate the function, composition of functions before you can do some calculus there. All right. So I'm going to number 3. Seems like number 3 is the easy part. So let's go to number 3. That is called a composition of function. F composed of G, substitute minus 2. Then we're going to do it by hand and then do it by calculator. We'll go do it by hand first because we can do this by calculator. So let's do it by hand first. That way we actually know what. Suppose you get into your calculus class next semester in fall, and you are given that, and you are told not to use your calculator. Some teachers can tell you not to use your calculator to take your test. So you got to do it by hand if he says that. Number 3, composition of functions. F composed of G. Whenever you're given F, the students call it fog. You can call it fog F all you want, but it's called F composed of G. So you're given 2 functions. The second one, whenever you're told to compose F with G, and G is the second one, it means substitute G into X. Substitute G into F. Okay, let's do that. Let's do that. So I wanted to see what I'm actually going to do. F, substitute the value of G. That's what I'm doing now. Substitute the value of G in the function f of x. So I have actually said that f composed of G, all right, is equal to f of G. Later on, when I finish, I will substitute -2. And that means wherever I see x in f, so I'm going to bring down the value of f. This is -5. You see, I see x here. So I'll put G there. And what is G? X squared plus 1. And then the integer or the constant in f is -1. So I brought down f of x. Wherever I see x in f of x, I'll substitute G. And after the substitution, tidy up. So I'm going to tidy up what I just did. I'll distribute -5 into the parentheses, minus 5x squared, -5 multiply 1, I have -5. Then there's a -1 outside. Collect like terms together. I have -5x squared minus 6. Therefore, f composed of G is this. F composed of gx. Let me just write it so you know. F composed of gx. This is what I'm doing right now. At this point, I will find f composed of g -2. F composed of g -2 means substitute -2 wherever you see x in the final answer here. Okay, so I have -5. Wherever I see -2, and I see -2 here, -2 squared and minus 6. -2 squared is 4. 4 multiplied -5 is -20. -20 minus 6 is -26. Therefore, f composed of g of -2 is -26. So let's use our calculator. You can check your work. It's always good to check your work if they give you this kind. So therefore, f composed of g of -2 is -26. We will check our answer with calculator. So let's check our answer with calculator. So I'm going to pull my calculator up. All right, and then I'll go to y equals. Turn it on first. Turn my calculator on. And go to y equals and clear my y1. And I'll put f of x in y1. So my f of x in number 4. For that, let me see. We did number 3. Okay, it's number 3. All right, so my f of x in number 3 is negative. Remember that whenever negative comes first, it has to be the one in parentheses. So minus 5x. This is the value of f of x minus 1. All right, so now the next one is y2. I'm going to put y2 into my g of x into my y2. So x squared plus 1. So x squared plus 1, x squared plus 1. So I'll go to the main screen. I'll go to the main screen, second quit, and then I will find my, first of all, bring down my f of x, y1. Remember, y1 is in f of x. F of x is in y1, representing the reverse. So verse, y verse, function y1, you bring down y1, and then you substitute y2 there, and y2 has your g of x, verse, y verse, function y2, and I'm going to close that parenthesis, and I'm going to open another parenthesis and put -2. Hopefully, if we put it on correctly, we should be able to get, let's see what happens here. That's not what we had before. So we have to retype it. I'm going to retype it and see. Verse. So the one we did by hand, it looks better. Substitute. Okay. I just want to make sure that this is let me see. Let me do it this way. See how it is. This one is just, and let me do the other one. Y. It's verse y verse function y2 this time. -2. And let me see. And let's see how this it will be. It's not. I'm going to come back to this because it's a way I can do it with calculator, but it's not working out. Let me. It's actually the way I put it in. So see, there's another way. So y verse function y1, and then I'm going to put in the other one, verse y verse function y2, evaluated at -2. Evaluated at -2 is not supposed to be this one. So I'm just going to look at this question and see, number 3. Note that every question has answers there. So actually, the one I did by hand is better. The one we did by hand is the correct answer. Okay, well, we can revisit this. We are going to revisit this. We answer with the substitution is the best answer there. Okay, one last one for this, and we go to other composition of functions. All right, so the next one is addition. Next one is addition. So we can put them in, we can do this addition here. We are told to evaluate at 5. So this one will be addition, and we can do, let's continue with composition of functions. Let's continue because that's what is more important. So let's do composite of function in number 5. Composition of functions in number 5. It can be done by hand. In this number 5, if we want to define something that is called a property, if f composed of g is equal to g composed of f and is equal to x, then the two functions are inverses of each other. If f composed of g and g composed of f and all equal to x, they are inverses of each other. So let's go back and do this. So the first thing we want to do is f composed of g, and we want to also do b, g composed of f, and f composed of f. All right. So the first one is f composed of g. Let's come over here. So the first thing I want to do is bring down the value of f. So that's x here, x squared. But wherever I see x squared, I should put in square root of 1 minus x. So I want to open parentheses right here. I'm going to leave this to where it is. Wherever I see x, I'll put in the quantity square root of 1 minus x. Okay, we all know that square root and square are opposite each other. Square root of x squared, this will cancel this. Therefore, our f composed of g, x is equal to 1 minus x. And that's it for that. So we shall say 1 minus x here. And then let's find g composed of f. G composed of f is the next thing we want to do. Okay. So where is my g? I'll bring it down. Bring the g down. G is square root of 1 minus square root of 1 minus x. But I see x here. Wherever I see x, I plug in the value of g. Because this time it says g composed of f. In other words, substitute f into g. That's what it's saying. Okay, so if I substitute f into g, in other words, I'm going to change this to f of x. If I do that, I will have square root of 1 minus, where is my f? F is x squared. So I'll put x squared here. And I'm not going to be able to change this. Okay, because even if I use difference of two squares, it's still not going to work. So I'm going to leave this answer like this. You can rewrite it. Square root is the same as 1 to root of 1 over 2. So, but I will rewrite it and say that g composed of fx is equal to 1 minus x squared all to power 1/2. That is the only way I can rewrite this. That's the only way I can rewrite this. I cannot take the square root because it's not a perfect square. It is not a perfect square. Okay, now the last question says, find f composed of f. F composed of f. Okay, so which means substitute f into f. That's all it is. So let's do that. So wherever I see f, I'll bring down f first of all. Because it's f composed of f, I will substitute that. Okay, so then I'll bring down the question. The question says find f composed of f of x. And then substitute f into f. That's what it is. So I will put down x squared. This is where my x squared is. So I just put that, empty something inside the parentheses. So this is x squared. So I'll put x squared again inside here. So it is x squared squared. And this is the same thing as x to the power of 4. So it changes to a quartic polynomial. Therefore, f composed of f of x is a quartic polynomial. Okay, so right now let's go to and I think you can do this one. You can do it. Okay, now let's go to number 7, the difference quotient. Before we write this, let's make sure we understand what it is. If I maybe in future or even now, you can be given a sector of a circle or a curve. You can be given a curve, a little definition of difference quotient, and there is a point here A and a point B, where the point A is x, comma f of x, or you say x, comma y. At this point, notice that if you complete a right triangle here at B, there is an increment in x. So here I'm going to write x plus that increment. Let's call that increment x plus h, where h is the increment. And therefore, here I will write f of x plus h plus h. All right. So if you're told slope of this line, whenever you're told to find the difference quotient, you're actually finding the slope. It's called the slope of a secant line. The slope of a secant line, the difference quotient. So what is the slope of this secant, AB? The secant of AB is a secant because it is a secant. Because the point AB, the line segment AB cut into the circle. I mean, maybe we call it a graph. We cut it to the graph. So it's a secant. Okay. So if it touches the graph at one point, we call it a tangent line. So you're coming to tangent line when you get to calculus. But for now, when you're doing limits, you get into the limit of a secant line. Okay. But say we have this AB, so we want to find the slope. Remember that the slope is, let's write it the way we used to write it. Okay, y2 minus y1 over x2 minus x1. But you know that y2 is the same as h. So I will actually, with your permission, change y2 and y1 to their function notations. Okay, so so here I'm going to write f of x plus h, f of x plus h, that's y2 minus y1 minus f of x. And then for the denominator, I have x minus x plus h. So this is the one with increments plus h. So note that this is the same as slope. This is the same as slope, but because we are using an increment, rewrite. So I'm going to rewrite this. When I finish, I'll call this slope the difference quotient. So the difference quotient is the same as slope. Okay, so I will just rewrite. When I rewrite this, I will see that the slope of this secant line, so the slope of that secant line is slope equals f of x plus h, which is y2 minus y1 all over x2 minus x1 plus h. So we will take away x1, we shall call them x. So let's take away, let's call them just x. All right, so this one is x plus h. And if I open the parentheses in the denominator, x will cancel with x. So I will end up with slope of the second line equal to f of x plus h. So whenever you're told to find the difference quotient, it's another way of finding the slope. So you put h here, and we can rewrite it, and then we can put negative h there, but later on. Okay, so find the slope of the second line. So this is a little bit of the meaning of a slope of the second line or difference quotient. But when you get to calculus, you will learn more about that. But we are starting this now because it's actually in the test. You need to know how to evaluate it. So we and it is in section 0.6. All right, so we are going to slope of the second line. I already saw it somewhere. Okay, I already saw it here. So I'm cleaning up so I can get here. And I can actually get the one that is very easy to do. Slope of the second line, that's very easy to do. That way, if there's not, we come back here. Oh, this one is the easiest one here. Okay, so I will actually like us to start with the one that is easy to do. And if not, I will actually pull up 5.6, 2.6 here. That way we will see an example that will help a lot. Because if not, it will look like it's going to be long. It is going to be long though, but you will see that you will still get it. Okay, and we're looking for 2.6. 2.6. We're looking for difference quotient here. Okay, I want to make sure I get that first. And I am looking for exact place it is so we don't waste time. So I'm looking for the difference quotient. See, that's why. Actually, this is what we're talking about before. We will see. I want you to see that all those manipulations are here. How you can do it with your calculator. They're already in your PowerPoint, so you can look them up. Don't forget to read your PowerPoint. If you understand the PowerPoint, there'll be no need going to the textbook. Showed you how to do it with calculator. Actually, you can also go to the examples in the calculator. The multiplications are here too. So function of a function should also be there. Okay, so well, this is actually the kind of graph I just drew, so you know it's in your calculator. It is actually in. This is what we just talked about. You will not be told to prove it. Trust me, it's not important. But you just need to know where we get the concept of difference quotient. The concept is actually from finding the slope. All right. So the important thing is that we should be able to evaluate difference quotient. We shall be able to evaluate 1. If we look at the original one here, the first example here, the first example they gave us, we're here because students have problems to do this. So, but if we can, okay, so we are looking at find f of x of h for this equation, the parent function of a quadratic function. Okay, so when you're given find f of x, all you need to do is substitute it in the equation. And that's it, that's that. That's that. That is that. Okay, so let's make sure that this video is not too long again. I'm going to cut it and then I'll cut it and I'm going to stop it.